We need to talk about the parabola now, and I have the formal definition here listed out for us. It says a parabola is the collection of all points P in the plane that are the same distance from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola, and the line D is its directrix. As a result, the parabola is the set of all points P for which the distance from the focus to any point is the same as the distance from that point to the directrix line. Alright, now that may be as clear as mud right now, so let's see if we can figure out what they're talking about. Here I have an example, oops, that's not very good there, an example of what a parabola looks like. It is actually just this blue curve. The purple line here and the red line are not actually parts of the parabola. It's just this blue curve. And we've actually already seen these before. In fact, we called them quadratics, or in our library of functions, it's called the square function. So right now we're just going to give it a better name. This is called the parabola. Now it talks about a fixed point F. That fixed point F in my example is right here, and that's what we call the focus. Notice that the parabola wraps around the focus always. No matter which way it is facing, it will always be wrapping around the focus. Now, that fixed line D that they were talking about is our directrix line. And that's what I have an example of right down here, this red line. That's our directrix line. Now they talk about how the definition of a parabola is, it is all the points in the plane. So maybe let's take this point right here, where the distance from the focus to that point, if I could draw a straight line, would be the exact same as the distance from that point to a directrix line. And it doesn't matter what point we're looking at. If I were to find the distance between these 2 points, it would be the exact same as the distance from this point to this point on the line. So that's what creates a parabola for us. Now there are some very special parts of the parabola that we need to talk about. This point right here that we have talked about previously, we used to call it like the maximum or the minimum. In fact, in a U-shaped graph that's pointing, that's opening up like this, then that would have been a minimum value, right? Well, this is also called the vertex, and we've also called it the vertex before in other problems. So we're going to be talking about it more now as the vertex. We have our directrix line here. We have our focus, which is this point. Now, this line that runs through the focus and it connects as its endpoints are points on the parabola. This line is called the latus rectum. It joins, goes through the focus and has endpoints on the parabola. Always. Now these things are all related to each other in a very specific way. If you'll remember, we said at the very beginning that every point along this curve here is the same distance from the focus as it is down to the directrix line. Well, we're going to use that because we're actually going to call that an A distance. So from the distance from the focus to the vertex is the exact same as the distance from the vertex to the directrix line. This is going to help us here in a little bit when we start talking more about these. Now also, because of symmetry and because of the way that these things are set up, there is 2A distance from the focus out to the endpoint of the latus rectum on either side, which makes the entire length of the latus rectum some 4A units.